Alright, to get us started, I have set up a really simple scene here with just this little blue sprite for the background, a couple of squares or rectangles with colliders on them right here, with colliders on them to act as our floor and walls, and a simple platformer controller with a little spawn for projectiles. So if I click play here, we can see that I can move around really fast actually. I can jump, and I can shoot projectiles only to the right. And that is because for our knockback purposes, we only just need to show knockback working. But what we're creating today will include the ability to knock back in both different directions. Now our player, because it does run off of a rigid body, we're doing a physics-based knockback today. The player can handle knockback, but we'll address that in a different tutorial where we use the knockback module for different things. But for now, let's just create a dummy for our knockback to happen to. So the first thing we're going to do is I'm going to collapse these items, and I'm going to create a brand new game object called, there we go. We're going to create a brand new game object called dummy. And on dummy, we are going to add a couple of necessary components. So I'm over here in the inspector. I'm going to add a rigid body 2D. This is our most important one, and we are going to freeze rotation on the Z-axis because every Unity 2D game is just a squish down 3D game, so the Z-axis does exist for the sake of spinning around. But we don't want that to happen unless you're making a weird physics platformer, so for now we are going to freeze the Z rotation. Next thing we're going to add, and again we're still in the player object here, I make this mistake all the time, we're going to add in a box collider 2D. Now you can make the collider anything you want, but because our dummy is just going to be our player but a different color, the box works fine. So talking about our dummy sprite, we are going to right click on our dummy parent object here, go to 2D object, sprites, and we're just going to create a square. Cool, press enter. We don't have to do anything else to it except make it the appropriate default video game enemy color, which is red. Yeah, I can mess with that. Sweet. Now, of course, just for funsies, we're going to make sure our dummy falls and is affected by physics. Sweet, gravity still works. Awesome. So now that is done, let's actually start working on creating our knockback module. So I'm going to go down here, and I'm going to right click in our inspector, create C# script, and we're just going to call this one knockback module. Now the method we are applying can be done in your movement script or whatever script you have that handles physics or movement, but I like creating our knockback module as a separate component that can be added to anything because this is a multi-purpose module. If you think about it, when you're doing stuff like wall jumping, dashing, or something that requires some kind of like lateral propulsion, that's just a different form of knockback. So this allows us to just add in knockback in and out. We don't have to create any booleans. If we need to disable knockback, it's just boom, right here. So we're going to double click on that, open it up, and the first thing we're going to do is actually destroy these two first methods. We don't actually need these because we are going to be dealing specifically with physics. So the first thing we need to do is create a reference to our rigid body. So I'm going to do it the easy way where you just create a public rigid body 2D reference like so. And you can do this, of course, with a fine game object component, but this just kind of foolproofs it for me if it's in the inspector. But again, do it how you want to. And this is all we really need for in terms of variables. The next thing we're going to do is create a method called public void add knockback. That's in parentheses, and it requires 2 arguments. We want a float for force, actually 3 arguments. Float for force. We want a float for the X position. And we also want a bool for apply up force. And this is important for stuff if we want to add like dashing. So the first thing we need to do is figure out what these arguments actually mean. So force is the amount of force that will be applied when doing a knockback, because a knockback is kind of just moving in an arc. And the cool thing about working with vectors inside of Unity is, since physics is handled for us, we're going to get a nice smooth arc if we apply force or a vector in a diagonal direction, meaning that both coordinates in the vector, the x and y, are filled in instead of one just being 0 and the other one being a number. So what we're going to do first is do an if. Make sure I'm tabbed in correctly. Boom, cool. We're going to make an if x pos, this is our next argument, is less than transform that position dot x. Now, the reason why we are doing this is because we're working in a platformer, and this allows us to just decide if we need to be knocked to the left or to the right based on the position of whatever has just hit us, instead of doing something like checking where it came from, checking the direction of force is going in, and then going into that force. This way we're just comparing two numbers, and we're like, hey, if you're coming from the left, bounce me to the right. If you're coming from the right, bounce me to the left. So in this case, if we're to look at a number line, we can kind of imagine that if the x position is greater, then the object is coming at us from the right side, because you know, if you're looking at a coordinate plane, the farther you go right, the greater the x value. So it's coming at us from the right, it's going to bounce us towards left because it's kind of traveling in that direction. So what we need to do is say if our x position is greater than our transform position dot x, and whatever just hit us is further ahead than where we're currently standing, I'm going to write a little comment here for us. The projectile came from the right, so we need to bounce to the left. And in order to do that, we are going to do RB, our rigid body. I added the underscore earlier because I thought it was a private. Don't need to do that. So we're going to do RB.velocity, which is how Unity handles movement of physics based. You know, velocity is just distance over time. It's like speed. We're going to do velocity is equal to a new vector 2. And then we are going to have our x value be our force, and our y value, or force times 2 actually, and you can make this number whatever you want. I just found that this gave us a pretty dramatic knockback. And we're gonna make our y value just straight up force. So what this is going to do is make our object travel forward on its x-axis and by whatever speed it has, and includes friction and junk. And this will kind of make our object hop up, so it's like it's being knocked into the air, and then the x is causing it to travel in a specific direction. Now this is great, except this is in the case of our projectile coming from the right. But since force by default is a positive number, this is going to also make it bounce to the right, kind of canceling out movement. So in order to go to the left, instead of going on the positive to the x, we're just gonna make it a negative. So that's cool. The reason why I didn't make this number negative here is if you want to create a public variable to adjust the force of the force of the knockback rather than like force times 2, this way you don't have to worry about making that negative. It can just be the negative version of the force. Now, just one more variable or argument we have to worry about, which is apply up force. So in the case of doing something like a dash or a wall jump, or like a wall dash or something like that, you don't usually want to jump up, or if you're dashing, you don't want to jump up. So what I'm doing here is we're going to take our force value and we are going to multiply it by an int version of our apply up force, because is that not gonna work? Oh, it isn't. All right, cool. One shortcut later and one rapid fire Google search, and I found out we're gonna have to use something called a ternary operator, which is a fancy kind of C# intermediate thing where you condense an if statement into a singular line. That's the best way my art brain can kind of perceive that. But what we're going to do is we're going to add a couple parentheses because we need to make this its own kind of separate line, where we're going to put our apply up force as our argument, and we're going to put this little question mark next to it, which makes it a ternary operator. So what this does is it says check apply up force and see if it's true or false. So in the case that it is true, we want to apply our up force, we want to make our argument 1. We're going to put a little colon here, and if we don't want to apply up force, we add a 0 right there. And this just kind of tells it if we should do our up force or not. Ternary operators are awesome. I love using them. So if you get to use them in your other code, go ahead and do that. Now, this other if statement I'm doing, you can do this in an else, you can do this in an else if, or not really because it's just 2 if statements, but I do it in an if because I'm weird and for some reason this makes me feel like the code works a little bit better. But we're going to check if xpos is less than transform that position dot x, and then we are going to just there we go, sorry about that. We are going to just copy this line right here, and since we're coming from the left in this one, always comment your code, because God help you when you're in the future and you wrote this and you forgot how to do it, or this video gets taken down for some reason. Comment your code. So if this projectile came from the left, so it's coming from this direction, we want to bounce to this direction. So we're gonna write bounce to the right. And remember how we added this negative to make it go to the left last time? Whoa. Why are you being so weird, writer? There we go, right here. We are going to just remove it. And that makes a positive value. Same thing if we apply up force, blah, 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 blah. Great. So now let's save it. Let's go back to the Unity editor. It's gonna do that complete domain nonsense. And let's go back to our dummy and drag in our knockback module. There we go. Drag in our rigid body to make this work. And click this. And cool, nothing happened. Why did nothing happen? Well, that's because there's nothing to actually trigger the knockback. So that comes into our projectile here. So both objects here, including the projectile, are physics objects. If we go to my projectile prefab right here, you can see it's just a circle, a little circle spray here for yellow with the color yellow. It has a rigid body on it. It has a circle collider 2D on it, and it has my projectile script, which takes in the force it's moving at and the rigid body. We're gonna hop into the script in a second, but for today's purposes, I made this a trigger or a collider here, because I always found triggers work better for actual collision detection with fast moving objects than solid collision shapes. So that's just something to take note of. So I'm gonna double click on my projectile script here. And we can see that it's pretty simple. It takes a float force, it takes a rigid body RB, just a reference to it, and we have a fixed update function here because we're dealing with physics, and we want, and just for the sake of moving the bullet, I have its velocity equal to vector 2.right times 12. I just need an arbitrary number to do that. Now what we need to do is we need to include something to happen whenever this object hits a trigger, or hit something that whenever it hits something. There we go. Whenever it triggers the trigger. So we're going to do a private void. You can also do void. I just get into a habit of doing this. Private void on trigger enter, and this is very important, 2D, because we're working in 2D and Unity will just not tell you you did the wrong collider. So we're gonna start off with this. On trigger, enter 2D, collider 2D, other. And what we're gonna do is now we're gonna do other dot get component. And inside that get component, oh, actually, here we go. We need if other dot get component. And inside that, we're gonna add knockback module, like so, to check to see if we're actually using the knockback module. Because if you do an if statement and you're just entering in like a class or something like that, it will return a null if it doesn't exist, or it will return the object if it does exist. In the case of an if statement, that will be true or false. So in the case of our object actually having the knockback module, what we're gonna wanna do is just have the same line here. We're gonna just copy this, paste it down here, and we're going to do the add knockback argument. The add knockback method we just made. So we're gonna take a float force. For our projectile, I made it a public float so I can mess around with it in the inspector. So I'm just gonna pop in force here. For our X position, we're just gonna do transform dot position dot X. So this is for where the bullet came from. And then finally, we're gonna say true for apply up force. Awesome. Now what we want to do is after the bullet hits something, that's Godot terms. We are going to destroy itself. So just destroy game object. And with that being done, this should work. So let's head back into Unity, wait for everything to cook. Let's go back to our main inspector so we can see everything. We have our dummy here with our knockback module. And we have our player here that can shoot the projectile. So let's try it out. Boom. Okay, that's pretty violent, but it's knockback. So if I were to reset the scene, I really didn't have to do that, but you know, just for posterity's sake. That was not a sentence. If I was to reset the scene and we go over to bullet here, we can scale down that force like a lot. 12 seems crazy, so we're just gonna do 2. Restart the simulation and boop. Look at that, a little bit knockback. Now, the cool thing about Unity is physics can be modified like a billion different ways. You can see all the arguments we have on our rigid body. But the really cool one is you can create something called a physics material. And what that allows you to do is to create a specific physics component that rigid bodies use to have it interact with stuff like friction or bounciness differently. So let's try making our own physics material. I'm going to go down to our assets folder here, right click, go to create, go down to physics material like this. Let's create a new physics material, and we're just going to call it knockback material. And if you see here, we have a lot of different arguments here. We have dynamic friction, which you can see here is how much the collider's surface friction is affecting it when it's moving. Static friction, which is self-explanatory, it's just friction when you're standing. And bounciness, which is the really fun one. I'm going to put this at 2. And then there's a couple new arguments here, actually. What? Oh, you can only put at 1. Okay, so this has maximum bounciness. So you have friction combined, which takes the averages of the 2 colliders. That's cool. And we have bounce combined, which takes the bounciness of 2 colliders. This is why I still like using Unity to an extent. It has all this stuff. Oh. So with this created, what we're going to do now is go back to our dummy, go to its material section right here, this physics material 2D, and drag this in. Now, it's not accepting it because I made a normal physics material. So what we're going to do is actually clear out this old one, and we are going to go back to create. We're going to 2D, physics material 2D, and now we can see we only have a couple arguments. There's where the new arguments are coming from. Call it knockback material again, but now we're going to just make sure our friction is about that. If you want a slick surface, like you don't want something to stick or just move on forever, I can set friction to 0. But if you want something crazy like I'm about to do, I'm on bounciness to V1. We're going real wild with this one. So we're going to go back to our dummy. Now we're going to drag in our physics material 2D. Let's see how this works. So you can see when it starts, our object bounces, because now it's the bounce thing. And if I time my shot, boop, boom. Look at that. It'll bounce a lot and it'll slide a lot. So this is another cool thing you can do, actually. It seems because of how close our object is when it's bouncing, it doesn't really want to work anymore with knockback. And because we turned our friction to 0, this is going to move forever because it's a frictionless surface. But the cool thing is this module can be used in a lot of different ways. You can disable it, you can enable it, you can set up a boolean in your main movement script to make sure if you have like a tank enemy, it can't be knocked back very far. You could have a bunch of modifications to just how knockback actually functions. Maybe you only wanted to go up, maybe you only wanted to go to the right. Great for physics games, and with a little modification we can do it for 3D, but that's for another tutorial. So that's a Unity one. Hope that helps. And now it's time to move on to the Godot tutorial.